All right, team, let's get right to it. We need to talk about one of the absolute fundamentals of what we do, the line between the client and the server. You know, getting this right isn't just about making sure things work, it's about making sure they're secure. So in this little briefing, we're going to break down exactly what that means and how we nail it every single time. Look, every feature we ship, every single line of code we write, it all comes down to this: the integrity of our application. This is what we're paid to protect. It's not just about cool features. It's about our users' trust. It's about our reputation. So here's the question every single one of us has to answer, every day. How do we actually defend it? And let's be clear, this isn't somebody else's job. Security isn't a feature you add later. It is built into the code from the very first line. And that defense? It starts with a really simple but incredibly powerful idea. You have to know exactly where your code lives and where it runs. Honestly, this one distinction is the absolute bedrock of web security. Okay, let's dive into the details. We've got to define our battlefield here, and it's a distributed environment with two main players. You've got the client and you've got the server. So at its very core, this is the architecture of the entire web. The client, usually just a web browser, it asks for stuff, and the server, that remote machine somewhere, it provides that stuff. It's basically a constant back and forth conversation, and our job is to make sure every part of that exchange is locked down tight. Okay, this slide right here gets to the absolute heart of it all. Just think about it for a second. Client-side code, our JavaScript, is literally downloaded and run by the user's browser. That means they can see it, they can poke at it, they can try to break it. But our server-side code? Nope, that stays safe and sound, hidden away on our server. The user only ever sees the final result, never the secret sauce. And this leads to an absolutely critical rule. Any sensitive logic, I'm talking business rules, database access, you name it, it must live on the server. No exceptions. So now that we're clear on where the code lives, let's talk about how we move data from the client over to the server. Now, there are two main ways to do this, and as the slide says, choosing the right weapon here is way more than just a technical detail. It's a massive security decision. And this table just lays it all out, plain and simple. With a GET request, all the data is just slapped right into the URL. It's totally visible to anyone who can see the screen. It gets saved in your browser history. It's in server logs. For all intents and purposes, it's public. POST, on the other hand, tucks that data neatly inside the body of the request, keeping it hidden from prying eyes. So the takeaway here is dead simple. For anything sensitive, passwords, personal info, credit card numbers, you use POST, always, period. Right, so we're using POST for our sensitive data. Great, but what happens when that data actually arrives at our server? Well, this brings us to a foundational, unbreakable rule, our absolute first line of defense. I want you to memorize this. Burn it into your brain. Write it on a sticky note and put it on your monitor. Never, ever, ever trust data that comes from the client. You have to assume that every single piece of user input is a hostile attempt to break our system until you have proven otherwise. Now, validation happens in two places. On the client side, sure, it's great for the user experience, catching typos, giving that instant feedback, but that's just a courtesy. It's a nice to have. The real security check always happens on the server. This is the non-negotiable part. It's what stops an attacker from bypassing our pretty front end and sending malicious code directly to our back end, the exact kind of thing that leads to devastating attacks like SQL injection. So think of it this way. Client-side validation is a polite suggestion. Server-side validation is the fortress wall. Okay, so we've secured the endpoints, but what about that whole journey in between? How do we protect data while it's zipping across the wild west of the open internet? Well, it all starts with IP, the Internet Protocol. The easiest way to think about this is like the postal service for the internet. It's the system that gives every device a unique address and is responsible for just getting data packets routed to the correct destination. Now, riding on top of IP, we have TCP. So if IP is just the basic postal service that knows the addresses, TCP is like the certified mail courier that requires a signature and guarantees delivery. It takes a big message, chops it up into little numbered packets, sends them off, and then on the other end, it painstakingly reassembles them in the correct order. And get this, if a packet gets lost along the way, TCP requests it again. It's what makes sure our data actually arrives complete and uncorrupted. But hang on, what if someone intercepts the mail?
See, IP and TCP make sure the data gets there, but they don't do anything to make sure it stays private. That's where HTTPS comes in. Think of it as the encrypted bodyguard for your data. It wraps that entire conversation between the client and server in a thick layer of encryption. So even if someone does manage to intercept the packets, all they're going to see is meaningless gibberish. That little lock icon you see in your browser, that's HTTPS. It's the absolute standard for any secure communication on the web today.
Okay, let's pull all of this together. It's time for an actionable checklist. These are the rules we live by when we're building our fortress. Let's run through them. 1. Always use POST for sensitive data. 2. Validate all, and I mean all input on the server. I can't say that enough. 3. Force every connection to use HTTPS. No excuses. 4. Keep your business logic on the server, hidden away from the client. And 5. Sanitize your data. This means cleaning any user-provided data before you ever display it back on a page. This is what stops attackers from injecting their own malicious scripts, an attack we call cross-site scripting. Seriously, these 5 rules are the foundation of a secure application.
And just in case you need a reminder of why rule number 2 is so ridiculously important, let's look at this classic, terrifying threat. With SQL injection, an attacker uses a simple input field, like a login form, to send database commands directly to our system. If we fail to validate and sanitize that input on the server, they can literally dump our entire user database. That is what's at stake here.
So I'm going to leave you with this one question to think about. A slick UI on the client side. That's like your front door. You can make it look great, but if your server-side code isn't secure, if you're not validating every single input and protecting your core logic, then you've basically left the back door wide open with a welcome mat. Our job as developers is to secure the entire house, not just the parts people can see.